going to take a look at question number 8-51. And in it, they show you a pentagon. They tell you it's a regular pentagon. So try to draw it as regularly as you can. And I'll show you how I look at taking the area of a regular figure. This pentagon with side length 52 feet, as given in the problem, is actually enclosed in a circle where each of these segments from the center, and we'll name it circle O, from the center to the vertex, or each vertex, is also congruent, because all radii of all circles are congruent. I will say that differently. All radii of any circle are congruent to each other. I don't mean to imply that the radii of all circles are congruent to each other. The radii of any one circle are congruent to each other. So what we can say in this case is segment OB is congruent to segment OA, because they are both radii of circle O. So I'm going to introduce my guest star, and it's going to be your job to identify who this is finishing this problem. Okay, you're up, guest star.
All right.
Boy. How do you want to start?
All right, so we know that since it's in a circle, it's 360 degrees, and then if there's, what is this? 1, 2, 3, 4, 5. What's 5? Pentagon?
You can actually write 1, 2, 3, 4, 5.
Is that a pentagon? Or?
That's a pentagon, yeah.
Alright, so if it's a pentagon, to find the interior angle, you can just do 360 divided by 5. Oh, what was that? Alright, so 360 divided by 5, and then you get 72, right? Alright, so you get 72 degrees for the interior angle, so that's your interior angles. So this is 72.
So we're going to call that the central angle.
Alright, wait. Okay,
of the pentagon.
Alright, so that's the central angle, and then what I would do from here is I'm going to just take one separate thing, like one of these 5, let's call this like 4, I guess. And then what I'm going to do is I'm going to split it down the middle. This is weird.
I know.
Alright, so then you got 2 right angles, and then we already know that's 90, and then our angle up here is 72. So
what kind of triangle is that?
That's an isosceles triangle.
Sure is. So go ahead and mark those sides.
And then like that, I guess.
And then mark the 2 sides congruent.
Yeah. Alright. And then we already know this is 15 feet long, right?
Yep.
Alright, so that's 15 feet. Alright, so then what I'm going to do from here is I'm going to split it into one of its own little triangles, just because it's easier.
So that's half of that isosceles?
Yeah, can I erase that? Like,
yeah, use the back of the pen.
oh, there's the back of the pen. Oh, that's cool.
Isn't it?
Yeah. Alright, so then there's one of these. Alright, so 15, since we're splitting it in half, so 15 divided by 2. I can't believe I have to use a calculator for this. 7.5. So now we have 7.5 is that, and then we don't know what this is yet, and we don't know what this is, but we don't really need to know what that is, so who cares? Alright, so
why do you want that?
well, because it's the height, and then we can use the we can just find the area of this.
Sure.
So that's what I'm trying to do right now. So we don't know what the height is, but we do know what one of the bases is. And we do know that this was 72, but now we split it into 2, so 72 divided by 2 is 36. So we know that this angle is 36. And then so 90 plus 36, I'm just going to use the calculator, is 126. So then 180 minus 126 is, what is it again? It's 54, I think. Alright, yeah, I was right. It's 54. So now that we know all of our angle measurements, it'll be a lot easier to find our height.
Can you do me a favor?
Yep.
And click draw.
Yep.
And color in the half of the triangle with yellow that you're taking the area of.
Right here. I'm taking all of this right here.
Okay.
Alright. So then back to, where is it?
Just click on the color you want. Was it red, blue, black,
don't know.
green?
Yeah. Alright. So now that we've got all of our interior angle measurements of this half of an isosceles triangle, so now we're going to use, now we have to find the height. So since we know that this is 54, we don't know the opposite, but we do know the adjacent, so we use tan 54 equals opposite, which is x, over adjacent 7.5. And we know that we're going to multiply both sides by 7.5, so then that just cancels out. We got 7.5 tan 54. Do that in the calculator.
You just hit 75.
7.5. Apparently I don't know how to use a calculator either. Alright, so then we get x equals 10.32. Alright, so we know that our height now is 10.32. And our, what's called, is 7.5.
Your what you called?
Our what's that called again? Base?
That'd be the base.
Yeah, our base. Drop the base. Alright. Alright, so now what I do from here is find the area. So find the area of this triangle. Remember, we didn't need this because it doesn't really matter, so yeah, he can go away. So half base times height, half of our base, 7.5, 7.5 divided by 2 is 3.75. Okay, so that's our base.
Or half your base.
Or half our base, yeah. And then times 10.32 times 3.75. So we get 38.7. So the area equals 38.7 just of this little half. So yeah, so that's just of that little half. And then
so you're looking at the area of 1/10 of that pentagon?
yes, because this is just half of that. So then there's 2 of these into here. So if you look, and there's 5, so there's 5 of these in there, right?
Yep.
5 of those. So then we found the half, which is 38.7. So
how many halves are going to be in that pentagon?
total there's going to be 10, since
Okay.
there's 5 times 2. So then what I'm going to do next is 38.7 times 10 because of the 10 halves, and then you get 387, which is your area for the whole pentagon.
Sure is. Yep.
Uh, 10 is really weird.
You're right.
Damn.
So area for that whole figure is 387.
Yep.
Fabulous.
Yep. I get extra credit. Bam.
Okay, go ahead and hit pause. That was an excellent solution produced by, oh, I can't tell you why. You have to guess who that was. And some of you are going to see that just a little bit differently. Some of you will see that as 5 triangles instead of 10. Either way is valuable. Either way works. If you happened to take the area based on 1, 2, 3, 4, 5, that didn't draw a pentagon the way I thought it might. Then you did the same thing. You still needed this height. You still needed this 36 degrees. You still needed this 54. So you still needed a base, only maybe you used a base of 15. So 1/2 base, which was 15, times height, which was 7.5 tangent 54, gave you the area of 1/5 of the figure. And at this point you should be pressing the buttons. For 77.42, it's approximately, I'm rounding, 77.42. And if we take 5 of those, because this is just the area of this 1/5 piece right here, we're going to get the same answer that our guest speaker got. So 5 times this area, 77.4, equals the area of the pentagon. This was the area of just one triangle. 5 times 77.4. And there it is again, 387 units. And these are squared units. So that's the idea. And in 8-5-2, you're given a different part, but it's still a triangle. It's still part of an isosceles triangle, so you can still create this right triangle here. This happens to be a 1, 2, 3, 4, 5, 6, 7, 8 octagon. So if you wanted to know the measure of this angle here, 360 divided by 8 gives you 45. So you know your central angle is 45 degrees. And if you want to find a height, you can use half of the triangle, just like our guest speaker did. Where this is now 22.5. So your trig skills will get you these measures that you need. You can find a base this way. You can find your height this way. And I'm happy to help if those skills aren't immediately coming back to you. I'd like to go through one of the polygon problems in 8-60. So let's look at C. Here's the illustration you've got for C. You've got angles marked at 10x, 8x minus 16, 12x minus 8, 7x plus 2, 9x plus 4, and 6x plus 10. That's 1, 2, 3, 1, 2, 3, 4, 5, 6. So this is 6 angles. So I know that 6 minus 2 multiplied by 180 will give me the angle sum. That's going to be 4 times 180, or 720 degrees in this figure. So I know that all of my angles added together will equal 720. 10x plus 8x minus 16 plus 12x minus 8 plus 7x plus 2 plus 9x plus 4 plus 6x plus 10. And you're going to go ahead and combine like terms and solve that algebraic equation. So that's 52 x's over there. 720 equals 52x Well, my pen has quit, so the rest, though, you are quite capable of figuring out.